Hi, everybody. Uh, Thank you for joining me today. We're going to be talking about finding advertising fraud and abuse on Android. Very excited to talk to you about this topic. Something I've been studying for a very long time, and I think that we're going to have a fun time talking about it. So, just indulge me for a minute while I talk about myself. I am a malware analyst on Android security team at Google. Prior to that, I was working at an ad tech company and have been studying ad tech for about 15 years. I think I first got interested in it seeing the injectors that were happening way back in the early Internet Explorer days on Windows XP. And while a lot of has changed since then, there's a lot of things that remain the same. And this space continues to be a very prolific problem across a lot of verticals, including Android. So I wanted to bring publishers, SDK providers, everyone together and talk to you about how we can find these type of problems and what we can do to avoid them moving forward. Um, in March of this year, Avast actually had a press release where they talked about adware and um, actually disclosed that about almost three-fourths of their detections actually relate to adware. Only 25% approximately of their AV detections are more malicious, non-adware related detections. We had the same thing on Google Play Protect, the team I work on in Android security. We started providing client-side warnings when programmatic clicking was taking place. That was back in 2018. Within that year, that became our number one detection overall. This is extremely prolific issue. Of course, we weren't defending against it natively on Android prior to that, so that's probably why it became such a popular venue for this type of behavior. I also find that many publishers who are appealing our decisions to flag things as unwanted software or advertising abuse, they are unaware that the behavior is actually happening in their app. They've usually signed up with some type of SDK provider who everything seems legit to the publisher at first, but then as their campaigns go live, the behaviors in the app are much different than what the actual app publisher is finding, even maybe even on their own test devices or in their own installations of that. So I'm going to first guide you through what I think are the main abuses in this space, and then also some tips and tricks to help you understand how this is happening within apps and also what you can do to possibly catch this stuff before you publish someone's SDK that might be doing nefarious activities. So, you know, because you're joining today, I expect that many of you understand the risks and issues, but I wanted to cover those first. So, abusive advertisements can cause overall device performance, but also extremely poor performance within your app. We've seen a lot of press coverage recently in the last few years, particularly starting in 2018 around this issue. And it can be devastating to a brand to have this come out with their app, especially when it's something that they, a third party's code that they signed up for. You also want to, of course, avoid warnings, unwanted software warnings from AV vendors. And, you want to keep your Play account in good standing. So it's important to avoid these type of behaviors. And in addition to the effects on your individual app, this can cause reputation hits with your marketers, your partners, and of course your end users who are vital to the success of your company. So we definitely want to avoid this behavior. But what are the behaviors that we want to avoid? Let's take a look at some of them. We only have half an hour today, so I don't think that we're going to be covering every possible violation, but I've broken them out into four major groups of violations that are generally pretty broad and cover the majority of issues. Definitely, there's many other cases, but this should cover the majority of cases. So the main issue that we first started tackling on the Google Play Protect side of things was programmatic clicking, or using Android APIs to automatically click on ads within apps or to inject JavaScript that does the same. As I mentioned previously, this became our most prolific flag in Google Play Protect in 2018 and continues to be a major issue. But it's not the only thing. We also have disruptive advertising. This can be where advertisements appear seemingly out of nowhere for the user. They can also interfere with core system functionality. You don't want your unrelated app to be throwing ads on the call screen or navigation screen of someone else's app. Um, you often find that adware will just pop-ups from the background while you're on the launcher, and it's very hard for the user to attribute where these ads are coming from. We'll get into this more later, but this is although may not be the most harmful aspect of advertising abuse, it's definitely the most noticeable to the user and has the greatest impact of your user reputation and the user experience. So it's very important to avoid this type of behavior, and we've been cracking down on it quite a bit on the Google Play, and we will provide unwanted software warnings for this type of behavior as well. Install attribution fraud is a little bit more of a niche problem, but it's extremely popular. Um, and this is basically what's happening is many developers on this call will probably be familiar with the pay-per-install model. And what install attribution fraud really is defrauding that model and claiming um, that your SDK or your ad was the reason for install when the install may have actually been organic or came from someone else's network. So um, the last thing that we'll talk about just briefly is spoofing. This is where you're misrepresenting your ad space to programmatic advertising networks. Um, you could spoof that the device is an iOS device, or that you may be claiming that you have video inventory for sale when in fact you might be running videos hidden inside of a static banner ad. It's something I see commonly. That would be allow you to conduct an arbitrage scheme where you're selling expensive video inventory that you only paid for banner inventory. This, of course, is fraudulent and something we want to avoid. So all these things on a whole are definitely major problems that need to be tackled individually. But let's start with disruptive ads because they are the most prevalent and obvious to the users. So disruptive ads can happen in a whole number of ways. Primarily, most often, I see them tied to some type of boot completed receiver. And this allows the SDK provider or the app publisher to launch some type of alarm manager or system event receiver in order to kick off ads out of context simply because the phone was restarted. So, for example, I could have a boot completed receiver that's tied to alarm manager and a pending intent and say, okay, well, every 55 minutes, my alarm's going to go off, and that's going to kick off some code that's going to display an interstitial. We've done a pretty good job in Android 10 and higher of blocking these activities from the background, but of course, many users are not yet on Android 10 and are still using older APIs, and they will not be blocked. So it's very common for browser windows and interstitial ads from a whole variety of SDKs to pop up from the background. It should be clear here that when I'm talking about SDKs popping up from the background, this may not be the fault of the SDK provider, but instead the way the app publisher or some intermediary is invoking the interstitial method can be harmful. In addition to using Alarm Manager, as I previously stated, you may just have receivers for various system events and then have a call chain that leads to ads based on when these system events occur. So I could just listen for like a power connected or battery percentage change. These can result in ads popping up from the background simply based on the user's use of the phone, which is extremely disruptive. Often I find that the advertisers who are doing this, or the publishers, I should say, who are doing this, they're often doing this in a way that's not easy to detect. And you're probably not going to see it when you install the app. They may a lot of times this is only invoked after a server-side response when certain conditions are met, such as your install time may have to be longer than 72 hours ago. This will prevent people testing the SDK, but also, compliance analysts on the Google side from seeing your behavior because, if you're testing someone's SDK, chances are you're not going to install it on your phone and then leave your phone for 3 days, right? So you look at it for maybe an hour or so, even less, and everything seems normal. But then, a few days later, you'll start getting pop-ups from the background. Additionally, this is not quite in the category of disruptive ads, but will lead to the similar penalties is having fake or misleading ads or deceptive practices related to your ads. So we've seen a significant abuse of the notification mechanisms, claiming that the notification is that, oh, you have a virus. You need to, I'm sure many of you have seen these ads both from interstitials in the browser and from the Android alert system, notification system itself, where the notifications are extremely misleading, just blatantly fake. And then when you click on them, it leads to some type of installation for some type of app cleaner or possibly even an unrelated package. Um, so anytime that any type of marketer is using a disruptive or I say a misleading prompt, that can also lead to the same type of penalties um, for advertising violations. So let's move on to programmatic clicking. This is much more subtle than the disruptive ads. The user is not going to notice it, but the your advertising partners most certainly will, and the ad networks are definitely going to notice as well. Programmatic clicking is where either the SDK provider or the app publisher themselves is trying to increase their revenue by creating fake conversions for an ad. And this is done in a number of ways, but the most common way that I see is through artificial motion events. This can be through the dispatch touch event, API, send pointer sync, on touch event. And it's easy to identify this type of fraud, especially when these type of API calls are not related in any way to an on-click listener. There's a whole myriad reasons to use these API calls in a legitimate way. But when you see, and we'll look at an example shortly, when you see code that is initiating these calls in a way that is obviously artificial, it's something to pay attention to. And one of the ways to you will see that the coordinates for the touch, for example, will be artificially sent and not based on anything that's passed by the user's actual touching of the screen. I've seen the fraudsters perform a click directly on an ad view using perform click. This is also very common. And then, of course, this is much harder to detect because it can be loaded under dynamic conditions, but often we do see JavaScript being loaded into ad views, and that JavaScript itself will either automatically load conversion pixels or URLs depending on the network, or the JavaScript itself will dispatch a touch event, and that will cause an artificial conversion. And the users don't usually notice this, but they may, because in some cases when the artificial conversion happens, right, you load like the products page or whatever landing page is part of the ad, so the user may be in an app and then all of a sudden get to some kind of a product landing page they weren't expecting. So that's one way that this can also be disruptive to users. But this is a very serious violation and is significant fraud. We see it quite often. It's something you want to make sure that any SDK you're partnering with isn't doing this kind of thing, because it can cause a lot of problems for your app down the road. This is not as high of a resolution as I'd like. Hopefully you're able to view this. But this is some sample code of a fraudster doing artificial clicks. And you can see here that they've actually, one of the reasons I chose this sample is they did quite a good job of naming their method. So it's quite clear exactly what they're trying to do. They have this check ads class that does all kinds of server-side checks and waits for JSON responses in order to conduct their fraud. We'll get into that in a little while. But so here they actually wait for a server-side determined amount of time, which is the delay click times 100. Once the time has passed, they will get the size of your screen, make sure they understand what the context of the ad is in terms of pixels, and then they will set the X and Y coordinates artificially, as I mentioned before, and ensure that those will fit inside of where the actual ad view is, and then they will send the motion event, which in this case is send pointer sync, and that will cause a artificial click onto the ad. It's quite interesting technique, very common, as I said before, and we've done a pretty good job of detecting this. We've seen more and more new tricks coming out in order to kind of get this code implemented, but this is a pretty straightforward example of how this is done at scale by quite a large number of fraudsters out in the ecosystem. All right, moving on to install attribution fraud. Again, another type of very, very common fraud. that has been happening in some very, very large apps over the last few years, and something I've been putting a lot of my own personal energy into stopping. Um, this can be a very, very profitable venture, which doesn't really, it is done silently and doesn't really cause a lot of disruption in the app. So it's very easy to get away with if people inside of compliance teams, security teams, or us at AV vendors. If we're not looking for it, it can go unnoticed for quite a bit of time, costing advertisers, particularly app publishers, right? Because what you're paying here for is an installation of an application. So the app publishers are the ones who suffer here, because you're signing up for a campaign with some agency, and you want to, when you pay, upwards of $6 for an installation, maybe more even, you want to ensure you're actually paying for an installation that was an installation provided by the campaign, and not some type of random bot or fake conversion sent to the network, obviously. So here's this graph here explains how this process works in detail. So if we look at this top row, items 1 through 4, this the typical install flow of a paid for app, right? You get the ad for the app. The user clicks on the ad. Oh, that's an interesting game. I really like to play that. The refer URL gets passed to the store, and the user installs and opens the app, and business goes on as usual. What's been happening with the fraudsters is that they are actually listening for this package added receiver. Most of the time, that's how they do it. And then they will generally, for the most part, there's many ways of doing this, but the majority of this is being done right now through refer broadcasts. Refer broadcast API, which we'll get into in a second, has been deprecated, but I continue to see a large number of third-party networks rely on this information. If your network or app is relying on refer broadcast, please look into deprecating that as soon as possible. You are almost certainly being defrauded. This is how the vast majority of this fraud goes down. There are other ways to do it, which I'm not going to get into in this talk, but if we could just eliminate refer broadcast as a way of attributing Play Store installs, we would reduce a lot of this fraud. Refers can be spoofed by anyone. Anyone can create this intent, so it is not a secure attestation method. You will not know that the referrer is actually the Play Store. In fact, we have fully deprecated this, and we expect you to rely on our HTTP API and not the referrer broadcast anymore. So going back to the fraud here, so let's say that there's an installation of a popular game. The bad SDK may be on any app in the system. You can declare permission to receive package added. So they just listen for the package added intent, and once they receive that, they say, this package added was at this precise time, so I'm going to record the time of this package. Usually they will send a request home saying, hey, is this package something in our network that we can get paid for? If it's a hit, they will respond back, okay, it is. Here's our campaign information, and they will broadcast that information to the system. And the app will receive it using the refer method I previously described, and generally then that data, the campaign who is paying for the installation, they generally get data from a number of sources, both fraudulent and legit. So generally on the back end, they have some way of filtering this, but those who are not filtering out install refer broadcasts are generally being defrauded by nefarious parties who are extremely common on many, many phones. So as I mentioned a number of times, and what I'll continue to iterate, is that we have deprecated this method. Refer broadcasts should not be used. This is as of March of this year, so we've had quite a long time that we've I've linked here a blog post from 2019. If you Google the word "still using install broadcast," this will come up right away. Definitely something to look into. You would be surprised how many third-party attribution networks are still using this type of method, which is not secure. I'm not going to ponder why they continue to use this. It can be self-evident to some of you. The reasons are various. They vary between publishers. Some folks have just completely depend on this because that's their internal system that they're using. If that's the case, try to get rid of it as soon as you can, because the refer broadcast is not safe. So as we've moved away from this, we have seen new techniques being adopted, but they are not as easy and definitely far less prevalent than the same old techniques I've been seeing for years related to the referrer broadcast. So if you take one thing away from this talk today, I would hope it be that make sure that any of your install attribution campaigns are not using the insecure referrer broadcast method. Let's look at what that method looks like. So this is just some generic pseudocode, right? We have this method A here, and what it's going to do is this is generally going to be inside of some code that received that recently packaged added um, the packaged added intent that I had mentioned before. So the receiver receives that your package has been added, and they say, great, this is a package that we promote and we can get paid for, so we're going to pretend that we're the Play Store here. This is this broadcast intent that says Android vending install refer. The Play Store is not actually broadcasting this anymore. We deprecated this, but anyone can make this intent. There's nothing stopping you from declaring it. And then they're going to put the refer into info that's relevant to their campaign, and then chances are, if someone receives this and accepts it as valid information, they're going to charge you for that installation, which can just be done just by simply knowing the legit timestamp of the installation and whatever referrer info they need for their partner networks. It's quite surprising that this continues to happen, but I think we're going to see it fall off soon. Okay, so the final topic that I want to discuss, as we have about 10 minutes left, is cloaking avoidance. And cloaking is where you are hiding a nefarious activity from either a compliance team like the Google Play compliance team, or an AV vendor, or possibly your partners, right? So you could have, like, say, a popular dating app or a popular game, and someone comes along and says, hey, take my SDK, it's fantastic, you will see such amazing CPMs. We pay triple our competitors, and test it out, it's great, right? You test it, they're expecting you to have an install, and they may behave completely as you expect, but then once they go live on the myriad devices across the world, then their behavior changes significantly. This sounds like a conspiracy or something that's far-fetched, but in fact it is essential to a large number of the fraudsters in the ecosystem. They benefit from this behavior as long as no one notices or catches them. So they're just going to continue to do it. For most of the folks who are committing ad fraud, the install is a commodity, and they have some type of scheme that they expect to pull out a certain percentage of return based on the purchase of that commodity, and they're going to do it regardless. So they continue to get away with that as long as no one sees them. So it's very important that we as publishers or analysts are looking for these behaviors in the right way, analyzing static code, figuring out, is code being loaded dynamically, and if so, why, and under what conditions, and then are those conditions something that we should be suspicious of because they're trying to maybe avoid some AV vendors or possibly us as the app publisher, right? So here's the most common tactics, and as I mentioned before, I've been looking at this space probably almost 20 years now, 15 years, and most of this hasn't changed across all the verticals, but it continues to happen because it's essential, really, for success as a bad actor in the advertising space. So what you're generally going to do is you're going to set up some kind of command and control server that is hooked to the installation or invoking of your SDK. So when your app's installed, or as soon as the SDK, whatever is triggered to load your SDK, you're going to call home with some type of information, generally about the individual install, and then also the system itself. This is where the beginning for emulator checks or suspicious IP addresses, or any condition that I may be suspicious of as a fraudster. It's most important to me as a fraudster not to get caught. So I'm very willing to give up legitimate users if I can be certain to avoid compliance officers, right? So I've seen many cases where I won't do fraud in California or Washington because Microsoft and Google offices and Apple offices are there, and I know that their employees are almost certainly to be in that region of the world. So I'm going to just avoid that altogether. Now, that is going to drop a lot of users that you could get high ROI on, but it also ensures that your behavior is not the same when you're installing something from Mountain View, for example. So generally, as I make this call home, I'm going to set up some type of unique identifier that's basically an install token. I'm also going to generally send up some type of persistent identifier along with that install token. And this helps me decide when an analyst may be installing me too often. Right now, oftentimes I see that they will block list my installations if, say, my device, so say a MAC address or Android ID, the advertising ID is, installing an app an abnormal number of times, right? Who knows what threshold they may set as reasonable, but most users aren't. A sandbox may install your app 15 times in just a couple hours, where that's not normal human behavior. Almost certainly, I'm doing something to debug or analyze the apps. They're looking for that. They're also looking for your ASN. If you're a big company and you have your own net block that's advertised in Aaron, right? I will, if I'm going to work with you, I'm almost certainly going to make sure that I'm not doing my malicious behavior if I'm, say, on a Google ASN, as opposed to like one that belongs to Time Warner or like some normal ISP that I would expect a normal user to be coming from. I've also seen massive block lists for common VPN providers. These VPN providers also generally advertise their address spaces in Aaron, some of them, and you can just block list all of them, as well as any cloud vendor, AWS or Google Cloud or Azure. Right, most of those IP blocks are well known and are continually blocklisted for bad behavior. So if you receive an install from these areas, you're probably not going to see the if you're looking for bad behavior in a test, you're probably not going to see it from there. So be wary of where you're installing from. And yes, so we've talked about that's just the general normal command and control setup for a normal adware vendor who's trying to avoid detection. So what can we do when we're testing someone's SDK to avoid their cloaking mechanisms? Well, one thing we definitely want to do is, if we're suspicious of a company, especially be wary from the start. If someone is offering you outrageous payouts, there's probably a reason why they're going. I mean, there's sometimes there's no bad reason for it, but oftentimes it's because they can afford it, because a lot of their conversions are just completely unreal or fraudulent. So we want to make sure that we're long-term testing on real devices. We want to make sure that when we get approached by SDK providers, we look into this company. How long has it existed for? Where did it come from? And is it the same website that I've seen 3 other times from 3 different vendors of the same name, or a different name, I should say? I've seen fraudsters reincarnate themselves over and over again using the same site templates, same privacy policies. Everything is the same, but the company name is the different, and they'll spam all the same publishers. Hey, come work with us. After their first iteration had been caught by, say, Avast or Google or another AV vendor, they will suddenly reappear under a new brand name. So look into the brand, see if it's reputable, but also make sure that you're testing their SDK under real world conditions, which would include having it installed for more than like a couple days, making sure that your installs, if they're expecting a paper install campaign, make sure that you're simulating those same conditions or install from the actual campaign, right? They may be checking your referrer info. An organic install is much different than a paid for install. And by not monetizing organic installs in a malicious way, I can avoid almost every analyst installation, because very few compliance folks are actually installing it in the way that's being installed in the wild. Additionally, if you've been testing their SDK in the time that someone has approached you, chances are they are watching your installations. They know, because you have some kind of agreement. Oh, here's my demo. Well, they're going to watch where that demo comes from, and they're probably storing that device's information in some type of database. Again, I know this sounds particularly nefarious or conspiratorial, but it is not as essential to their success as fraudsters. So if you test the device during the pre-launch phase, keep it running, but also you might want to ensure that you install on a new phone, because they may be well aware that phone belongs to your corporate entity. Again, as I had mentioned before, avoid if your company or shop uses an ASN that's published on Aaron, don't probably install from there. Also, make sure you're avoiding common VPN providers and cloud environments. This may be difficult, but can often lead to different results than what you would expect. Cool. So, with only 1 minute to spare, that is my whirlwind tour of Android advertising fraud. I'm going to pause here for a moment, and I think we're going to take some uh, questions from the audience now. Okay, so recommendations on tools for scanning. That's very good question. There are some sandbox utilities out there. I personally believe they are well tested by nefarious vendors. Most of the static analysis you're going to want to have to do through typical Java decompilers. Jeb is the commercial one. There's a JDEX, which is free, but probably you're going to have to perform static and dynamic analysis on the apps just as you would in a normal malware analysis situation. Um, I see oftentimes that the advertisers who are motivated by extraordinary fortunes are actually well ahead of some of the more malicious malware families in terms of their cloaking techniques and their abilities to hide from AV analysts because they're significantly motivated. So my broad response to this question is generally going to be the same tools you would generally use for Android malware analysis. You would want to use for this. We have completely proprietary tools at Google, and of course those are not available to you all. So um, yeah, I don't have any good recommendations for that. But I would say that Jeb is an excellent decompiler and does a great job of deobfuscating. I don't have any affiliation with them or anything like that, but I have had very good experience in my own personal APK analysis with that proprietary tool. Okay. I think we may be nearing the end. I don't see any more questions up here. Great. Well, I really hope that this was a good experience for you all and that you learned something about advertising fraud. Feel free to reach out to me on the Talk Talk forum if you have any additional questions that you may think of later. I really appreciate your time today. Thank you, everybody.